Most people think the internet fails when something breaks. A cable is cut, a server crashes, a data center loses power. But sometimes the internet stops working even though nothing is broken. Websites remain online, computers still respond, networks continue operating normally, and yet entire regions suddenly cannot reach services they use every day. Not because the internet went down, because the internet went somewhere else. This is the unseen system that decides where every piece of internet traffic goes, even when the destination hasn't changed. Typing a website address feels like a direct action. You enter a name, your device finds the location, the server replies. It feels intentional. But the internet has no natural sense of direction. There is no universal map stored anywhere, no global routing center, no master navigation service guiding traffic. Every connected network only knows the neighbors it can hand traffic to. Nothing knows the full path. So when data travels, it isn't following a planned route, it's following a sequence of decisions. Each network simply claims, "I can get you closer." Your data accepts the claim. Then the next network makes the same decision again. What feels like navigation is actually a chain of trust. The global internet is thousands of separate networks owned by different organizations. Internet providers, cloud platforms, universities, financial institutions, governments. They constantly talk to each other. Not about users, not about content, about reachability. They announce which address ranges they can deliver traffic to. The message is simple. If you want these destinations, send the traffic to me. These announcements happen continuously, automatically, worldwide. No approval process confirms them first. Other networks accept them immediately, because if they waited, nothing would connect in time. The internet depends on rapid agreement more than careful verification. Speed keeps it alive. Trust keeps it functioning. Imagine a city where anyone can place road signs. The streets still exist, cars still drive, drivers follow directions. But one sign points toward the wrong highway. Nothing is broken, yet traffic disappears. Online, the same thing can happen. A network can announce a destination it doesn't actually serve. Not by breaking into systems, not by stealing data first, just by making an incorrect claim. And other networks believe it, because belief is required for connectivity. So traffic changes course. From the user's perspective, the site fails. From the network's perspective, everything works perfectly. The packets arrived exactly where they were told to go. Sometimes this happens by mistake, a configuration error, a mistyped number, an automated update applied incorrectly. Within seconds, large portions of internet traffic can be redirected through the wrong provider. Services appear offline. Companies scramble to investigate. Then, minutes later, everything returns. No attack occurred. No hardware failed. The internet simply followed incorrect directions temporarily. These incidents are brief but enormous because small routing changes influence global traffic flows. A single announcement can affect millions of connections simultaneously. If a wrong announcement can move traffic by mistake, it can also move traffic intentionally. The system doesn't distinguish motive. To the network, an instruction is an instruction. Traffic may pass through unexpected locations before reaching its real destination, often unnoticed, sometimes monitored, occasionally blocked. Users don't see a reroute, only momentary errors or slower connections, but the path their data traveled has changed, not through hacking, through persuasion. The internet continues to operate because networks watch each other. Monitoring organizations detect unusual routes. Operators manually correct mistakes. Connections recover. But detection takes time, and during that time, the incorrect path is considered valid. The system was designed for cooperation among trusted participants. Security was assumed socially, not enforced technically. Modern scale has changed the participants, but not the assumptions.
For most users, routing sounds invisible. But many modern systems depend on where traffic travels, not just whether it arrives. Banks evaluate login risk based on network location. Streaming services enforce regional access rules. Security systems flag unusual connection paths. When routes suddenly change, behavior changes with them. A legitimate user can appear suspicious. An automated defense can block a normal request. A payment can be rejected even though the user typed everything correctly. Because the system didn't fail, the path changed. Sometimes entire services temporarily distrust their own customers, not because identity was wrong, because geography appeared wrong. The internet quietly decides where you are based on who delivered your traffic, and routing determines that delivery. This is why routing incidents rarely look dramatic. No explosion, no outage banner, no visible attack, just subtle symptoms. A login that won't work, a verification code that never arrives, a connection that loops endlessly. Users retry, refresh, switch networks until the route returns to normal. Then everything works again. Nothing was fixed locally. Agreement simply shifted back. We think online locations are fixed places, servers sitting somewhere waiting to be reached. But the internet doesn't route to locations, it routes to claims. Your connection follows whichever network currently convinces others it knows the way. Reality online is negotiated continuously. Paths exist only while networks agree they exist. Change the agreement, the destination moves. When a website refuses to load, we imagine failure. But sometimes every computer worked correctly. The systems responded, the infrastructure held, the network behaved exactly as designed. It simply believed the wrong directions. The internet did not collapse. It was guided elsewhere. And for a brief moment, billions of requests traveled confidently to a place that was never their destination. If you want to understand the hidden infrastructure that quietly shapes everyday life and what happens when it starts to fail, subscribe to Unseen Systems. Because the internet doesn't always break. Sometimes it just listens to whoever speaks first.